Next on stage is Klaes, the head of Department for Neurotechnology and one of the chairs of the conference. So he will give a short welcome address and we'll start with his first opening lecture.
Thanks, Arthur. Welcome everybody to this year's VR Summit 2024. My dear guests and esteemed colleagues, I want to present to you this event that is in its second installment. So we started in last year, and when I started with our Health Plus Incubator, which is sponsoring this whole event, my idea was I wanted to have something that is inspiring everyone, a new technology that is usable and something that brings together entrepreneurs and scientists alike to start something new. So we are looking back at one successful installment already, and I hope that this is like a continuation and we will have many of these meetings again next year and the years after. VR and augmented reality and also AI have fused in many ways, and there are remarkable advancements in especially healthcare. As the minister already said, we have people that use VR for rehabilitation in different contexts, for mental health rehabilitation, also for physical rehabilitation. For a couple of days ago, we had the Connect 2024, so that is the event that is yearly done by Meta, and they announced their new technology, their new VR headsets that are now costing like $299. So the technology will be more accessible. They also presented augmented reality, like new glasses in collaboration with Ray-Ban, that allow you basically to see the physical, your physical surroundings, and at the same time have overlays in virtual space. So these two spaces are fusing, and VR is also used as a powerful tool for medical treatments and other rehabilitation purposes. And AI is like the big overarching architecture that is binding this all together. So even for these presentations of Meta, they also introduced their Llama 3.2 model, which is super powerful and can detect images and can give you feedback. And imagine that combined with augmented reality, where you can basically see something and the AI helps you interpret your environment. There's also like a plethora of options for new ways of helping people with disabilities, for example, in this regard. I think I am super happy that every one of you appeared today. I know that we also have a big audience online that is super nice, and it fits the theme that we have people that are or that more people are actually attending this event online than in being physically present. We have a lineup of 2 days of very interesting talks. We have everything starting from social questions, mental rehabilitation. We have education in VR, so like using VR to educate people in classes or for specific professions. There are talks about technical implementations and new ways of using this technology and what kind of progress we are doing there. Of course, there is gaming. It's not a small part of VR, it's a big part, but it's an important part because gamification is important, particularly also in all kinds of healthcare applications. We have a panel on security, safety, and ethics today, actually, and we have a nice poster session that goes along with that and demos in the makerspace. And I don't want to forget, of course, our hackathon, which will take place on Sunday. There are many real-world examples of what is already possible, like, for example, neuro rehabilitation for stroke patients in VR and social interactions, for example. And mostly I want to, already at the beginning, thank our great team of technical support and organization that is also present here for making this all possible, because this is not like a one-man show or something like that. This is a team effort, and I'm super happy that everyone is like working so nicely together And that also shows us that people are really enthusiastic about VR and AR and AI. And yeah, with that, I want to close this welcoming notes, and we will actually slip over to the first talk of today, which I will also give. So I will introduce myself quickly in a sec. And once again, thank you for attending the VR Summit 2024. So, do we also have a beamer? Because this is only the other thing. Okay, I use the time to introduce myself. So I'm Christian Klaes. I am the head of the Neurotechnology department at the Ruhr-University Bochum. I deal with mainly with brain-computer interfaces. That is one of the core research that we are doing in my lab, and we are also heavily invested in virtual reality and using virtual reality for neurorehabilitation. We have used virtual reality, for example, to make a virtual reality test suit for different motor disabilities. There's a poster over there that one of my PhD students is presenting. And we have used it for example, for an exoskeleton and similar things. And we are using it also for research because VR allows you to create all kinds of experimental setups that are very expensive or almost impossible to actually do in reality. So I will try without a beamer, but okay. My talk for today will be virtual bodies. So it will be relatively general, but I hope that it gives you a good introduction. And I will start with I'm not sure if I can start the movies also that are in the talk. Can you start that? So this is from, as you have seen in the title already, this is from the movie Avatar. There was a recent new installment not too long ago, but this is from the first one, if we can start it. Okay. Or can I start it with using this button or something like that? No, apparently not. Okay, green button. Ah, okay. So this is from that movie, and it shows you like a future with very advanced technology, where you have people like the main character. Interestingly, in this movie, is someone who is actually disabled himself. He's a paraplegic and cannot move, but he uses some kind of neural interface, which looks a little bit like an fMRI device. And he uses this device basically to control an avatar. So that is one of the main concepts, right? Your embodiment. And in this case, this is one of those native inhabitants of that faraway planet. Looks slightly human, but we will come back to that later. But they are larger than humans and stronger and so on. And he can completely control it. He's completely immersed in the perspective of that character. So how far are we with this technology? We can do not exactly that, but we can at least give you the impression of being somewhere else with VR. So the talk will be divided the following way. First of all, I will talk about what our body actually is. From a neuroscience perspective. I will talk a bit about artificial bodies, so that is when I will talk about disabilities and the potential of neuroprosthetics. And then I will switch over to virtual bodies, so what the future will hold, basically. So, what is our body? In principle, if you take it very technical and very unromantic, I would say, it's a collection of sensors and actuators. So we are sensing the world, we are controlling our body, and that is what makes us feel to be in control. We will come back to that in control theme later on. And this is all bound together by feedback loops. So not only are we controlling and sensing our environment, but we are also getting feedback, and that feedback is used to basically calibrate ourselves in this body that we have. And this gives rise to an internal model. So we are actually projecting all these inputs that we get, or our body is projecting all these inputs that we get into our somatosensory cortex. We get vision, and that is projected into our primary visual cortex. And all this together binds together a model where we think that we are right here, right now. What we do know as neuroscientists is that we are actually stitching together our reality, because when we are looking around, we're making small saccades and we are just seeing snippets of the environment, and from that our brain is puzzling together a three-dimensional impression of ourselves. We are not having that directly, it's a constructed environment. So there are two terms that are used in this regard. One is the body schema, which is shown here. This is basically our postural model. So where are we in space right now? So if you close your eyes and you're moving your hands, then you might not exactly know where your hand is, but you roughly know where it is. We have proprioceptive sensors that help you with that. And this model is action-oriented, so it contains ways of handling or making specific movements. And it can be relatively easily fooled. I will show you that later. And it can also be simulated. The other term that is often used is the term of body image. That is something I will not talk too much about, but this is the social construction of what our body is. Also sometimes our self-perception, so how do we feel when we are looking in the mirror? How are we responding if someone else makes a compliment, or if someone looks strangely at us? This can also be fooled, and this can also be transferred, and I will also talk about that a little bit later on. So I already said that what binds our sensors and our actuators, so our muscles and our senses together, is a model that is coming together in the brain. So this is the neocortex. That is basically the part or the realm that we are living in. And it is split up typically in parietal, occipital, and different parts of the lobe classically. And this particular area that you see here slightly grayed out, that is either on the one hand the somatosensory cortex, which is on the parietal part of the brain, and then you have the motor cortex, which is on the frontal part. So there's this divisive line over here that is the central sulcus that divides basically the brain in these two halves. And in the somatosensory cortex, you have this so-called cortical homunculus. This is your representation of yourself from all the sensors that you have onto your cortex. And you can see that this particular parts are bigger than other parts, and that is not by accident. That is because certain areas have more sensory input than others. So our hands particularly are heavily sensorized, whereas our back, for example, is not. And on the other hand, so on the frontal part, we have the motor homunculus, which is similar, but this is for basically our movement. It's also organized in a similar fashion and represents all our muscular activities that we can do. So speech is actually seen as a motor task in this regard. So here we have, that is the funny thing. So if you look back at this, it's just a very funny fact that in the German textbooks or in European textbooks, this is not a German one, but English one, you see the genitals here. In the American, they are a bit conservative, and the homunculus is wearing a shorts here, which I found very funny. But I can assure you that in the real cortex, we don't wear shorts. But, anyways. So this is how the homunculus would look like if you would blow it up into a 3D image. So one professor here from the Ruhr-University made this homunculus a long time ago. And you can see it has these humongous hands, and that's because of these heavily sensorized hands that we are using. And the lips also there are lots of sensors in your lips and your tongue, but not so much in the back and the rest of the body. So how can we use or manipulate this body schema, or how is it sometimes manipulated? So first of all, this image needs to be updated because we grow, right? We are little when we are born, and we are growing up, So all these maps that I've shown you have to adapt accordingly. And if you have some kind of accident, for example, if you get if this thing happens that you need an amputation of some part of your body, then suddenly something disappears from your body scheme. That gives rise to many complicated situations, which I will also talk about. But the thing is that, or the main point I want to make here is that there is cortical plasticity that changes this self-image over time. So this is also used, so if you think about the sensory cortex, that is what I just described. For the motor cortex, it's the same thing. So we are also adapting to the tasks that we are doing. So if you are learning a skill, then the representation of that particular part of the body that you are using are changing. So here you have, for example, bow shooting. Or if you, for example, play a piano, then typically the representations of your fingers get larger. It also, as I said before, helps with recovery from injury. So if you have some kind of damage to your body, then this has to be updated in your cortical map as well. And as I said, aging and change as well. So there are also, those are the advantages. This is what the system is made for, but it also gave rise to a couple of maladaptions, so things that are going wrong. So for example, I mentioned piano playing before. There is also the medical condition of focal dystonia, which means that in your brain, your representations of your fingers have merged. And suddenly, because you overlearned playing the piano, you are unable to not move two fingers at the same time because their representations in the brain have merged because of this overlearning process. This is considered a maladaptation, and you can use therapy to get rid of that. After amputation, there could be, I mentioned the case, there could be the normal way of that you are just losing that representation, but you can also develop what is called phantom pain. That means that you are feeling your limb that is actually not there anymore, and that can cause pain, and you also can use some kind of therapy to help that. And there's VR therapies for exactly that already. There's other distortions of the body schema. So if you are unable, for example, to draw the full clock. So this person has been told to draw a clock, and as you can see, the person only drew the right half. So this is called neglect, and that happens, for example, after stroke, or can happen after particular types of stroke, that you are basically neglecting a part of your body or of the visual environment that you are seeing. The phantom limb, I already said, there's actually quite a lot of different types of phantom limb problems that you can have. So there is, for example, the phantom pain that is more a simple case. Then there is like the problem that you might think that a part of your fully functioning body does not belong to you. So there are cases where people are actually saying this arm is, it's called alien limb syndrome. So you are thinking that your hand, for example, does not belong to you, even though it's perfectly functioning and it's working. But that has to do with your representations in your brain that are distorted or damaged, or that you have misperceptions, that you think your arm is bigger than it really is, or smaller, or that it, as I said, doesn't belong to you, or different versions of that. So that the one condition that I just mentioned is called somatoparaphernalia. That is the condition where you are basically thinking that some of your limbs doesn't belong to you. That's also what the alien hand syndrome. To show you these illusions that you can generate using your body scheme, I will show you a short video of an example of what is called, or has been popularized as the so-called rubber hand illusion. And I will just describe the experiment, and then I will show you the video. So the idea is you have a person sitting in front of a table, and the real arm is under the table. The real left arm is not visible to the person, like either under a table or there's some kind of blocking piece of cloth or so. And then you have this rubber hand that is placed roughly where the arm is supposed to be. And then the experimenter is making particular movements and coordinates the movements of his hand, like stroking the fingers of the rubber hand at the same position as the real hand. And after a while, that's a very, very short while, you will adapt this rubber hand as part of your body scheme. And that has very interesting effects, as you can see.
That's weird. That's really weird.
Tell me when you're there.
Yeah, I feel it.
Feel it?
Yeah.
Don't move.
Oh no. Oh no. No! No, no, no!
So,
What the hell was that?
I'm
Yes!
sorry. Are you okay?
so this feeling of ownership of the rubber hand can be so strong that you are trying to protect it. So because she cannot move the rubber hand but her real hand, and she thinks her real hand is the rubber hand, she's moving back her real hand. And that is happens after a very short time. We can also see that there's evidence that this has to do with our representations in the brain. For example, in this experiment, people have used scanners, so MRI scanners, to scan the brain and see what parts of the brain are active while people observe certain videos. And in the first case, so for in this panel called A, they are watching a video of a real hand grasping an object, and then in panel C, they're seeing a virtual hand, or so not real arm, but a virtual representation of the arm grabbing an object. But this is with a high grade of detail. So this a couple of years ago, actually many years ago, 2001. So that is a high resolution hand at that time at least. And then in E you see an even more abstract representation of your hand. And you see that partially the same parts of the brain are active, but partially also things are missing. So particularly if you look at the right hand side. So you can fool your brain, but only to a certain extent. So there needs to be some kind of similarity, also for the rubber hand illusion. So the rubber hand has to look like your own hand. If, for example, the skin color of the rubber hand doesn't match your own skin color, then the effect is reduced, for example, or if it looks smaller or in a weird position. In monkeys, this has been studied invasively. So, of course, in people, you cannot really measure neurons in the brain directly, but in monkeys, it has been tried out to see what happens if the monkeys train to use a specific object. So, in this case, the monkey had the task to basically grab objects from a table, and he used his own hand. And there are neurons that are representing where your hand is and where it can reach. And before tool use, you see that only where the actual hand is, or the neuron is only representing the hand or the space where the hand of the monkey is. But after tool use, you can see, so after the monkey uses this rake thing to grab his reward, which is like little grapes, he does that very, very often. So he has to do many, many repetitions. But after that, the neuron is not only representing the hand, but the entire tool. So you can think about that in a similar sense if you're using a computer. You are using the mouse and you're moving the mouse in this plane, basically, right? But the cursor on the screen is moving in this plane. But after a while, you're not thinking, I'm moving my hand forward to move the cursor upwards, but you're thinking, I just move the cursor upwards. So that is one of the effects of this training and tool integration into your body. There's this control experiment where they basically only gave the monkey the rake, but he didn't have to use it. So you can, and then the neuron was just representing the hand again. So it depends on you actually using and interacting with your environment to acquire this body scheme. There's also neurons that are showing where your reach space is, and these are also extended after tool use, as you can see in this image. Another very interesting thing, which I will just briefly talk about, is mirror neurons. So that is the effect that actually there are neurons in your brain that not only represent your own actions, but also actions of people that you observe. So this neuron fires because you are, in this case, fires because the monkey is grabbing that object, but if the experimenter is grabbing the object, the neuron is also firing. And people have suggested that this is a mechanism for imitation and empathy. Another interesting case is where it goes to the body image that I talked to initially. That is from the Mel Slater group. Mel Slater was here last year as VRS and gave a keynote speech. He's doing VR for ages, basically, before it has been popularized. And he has tried out many things. For example, he tried to see what happens if you're using an avatar that is not representing your own gender or ethnicity. And in this case, he looked at people that are either training and looking in the virtual mirror and seeing their body being white or black. And he observed that after this exposure to a body scheme that is not, so a black body scheme, if you are white, for example, that the initial racial bias, which is like a test case to see if people have a certain initial implicit bias that is not overt but not more like implicit, and they have measured that before and after the exposure, and they could see that this is reduced if people are basically using a body or a virtual body that is not of their own ethnicity. So there is potentially chance for making people understand the other better by putting them actually in someone else's skin. So the same could potentially be used if you are using avatars that are in if you are using an avatar of the opposite sex, or if you are to understand people in different positions, putting people actually in the place could help. So that is just a small study in that regard. There's probably many more things going on right now, and maybe some of the speakers that we have will also talk about that. Now we come to artificial bodies. So do we actually need a body to live? So this is from another movie. This is the new version of RoboCop, an old 80s movie. And here he he wanted to see what is actually him and which parts are the machine.
No.
And he's a bit surprised that there's not much left
Holy Christ.
of his actual body.
Holy Christ.
And
Holy Christ, there's nothing left.
and the interesting thing here is that the scientist here on the right is saying,
your body may have gone, but you're still here.
so the idea is that he has some replacements, and he is
It's
even
not
has
even my brain.
yeah, he has even implants
We
in
had
his
to
brain.
repair
But
the
still, the
damaged
point
areas,
is
but we didn't interfere with
he
your emotion or your intellect. You
is in control.
understand
He has control of his body, and that's what makes him
You're in
himself.
control.
You are in control. So and then he says, okay, don't put that back again, and I don't want to see it ever again. Anyways, so this leads us to artificial bodies. And for controlling artificial bodies, you would need something like a brain-computer interface. So that is a schematic overview of that. So you have the brain on the left side here with the different areas, and you already see that there's a little implant on the that you can see that is actually going through the skin. And there's 2 electrodes in this case. This was for an experiment in the US. So these are so-called Utah arrays, so small electrode arrays that are implanted in the brain. So they're stuck in the brain. I will show you later how they look like. And they record data from the brain. So this is called the neural signal source. And then this is all passed into a computer and run through what is called a decoder. And the decoder is something that is very, very similar, or basically from a technical point of view, it's the same thing as all these machine learning tools that you're using nowadays, like ChatGPT or the image classifiers that I use. They are all using a form of decoder or somewhere in their architecture. And the thing, what this thing is doing is using the neural signals and learning to map a representation of this neural activity to actual actions. And you use these actions then to control an effector, which can be a cursor on the computer screen or an actual robotic hand. And you can close this loop by actually projecting information back into the brain by stimulating through these same electrodes. Usually they are then in the somatosensory cortex, and eliciting some kind of percept that then is integrated into your body scheme using the mechanisms that I've shown you before. So this was our patient, Eric Sorto. We had him for 3 years from 2013 to 16, and he was keeping the electrodes even longer. You can see that on the outside you have these connectors on top of his head. These are amplifiers that amplify these very weak signals from the brain, and this is why they use this percutaneous connector. So this is going through the skin, as I said, and then the cable connects to a computer, and that is actually doing the connection. He's a tetraplegic, so he cannot move anything below his neck, and he was using that in the lab in the US for various purposes. I will show you in a second. Unfortunately, what I heard, the message I got in the beginning of the week is that he passed away. So he passed away, I think, on Monday. Very sad. He was a very cool guy, and as you can see, even though he had a lot of hardship because of his tetraplegia, he still tried to make something out of himself and had tried to do a job and do stuff. It's very sad. Here you see him in action. So here he is using what is called an MLP, the modular prosthetic limb, developed in a DARPA project in the US. This has all the 27 degrees of freedom that a natural human arm would have, and here he only controls 2 of those degrees of freedom to control this little ball there on the screen, and he tries to basically follow the red square and basically touch it, and that would be his task in this particular case. So that was controlled, and then I said that we also have the whole feedback loop by providing information back. So here we have the same robotic hand, but this one has little sensors attached to each of the fingers and to the palm, and these fingers, when you touch them, an electrical pulse is sent to electrodes that are implanted in the region that would normally get the information from his real arm, and thereby creating for the patient the feeling of a tingling at the position where the real arm is. This has been used also in the US in another lab. So here's the experiment. He's blindfolded, and the experimenter is touching different fingers, and he can actually tell which fingers in the robot arm it was. So this has all been a couple of years ago. Meanwhile, Elon Musk did another, he's a chain founder, and he founded this company called Neuralink that is probably not as well known as Tesla or SpaceX, but it was founded in 2016 to commercialize brain-computer interfaces, and they came up with their Neuralink N1 device, which is actually fully implantable, so it doesn't have this external connector. Processing is done on a small chip that is basically put in place where the normal bone of the skull is, and this is using wireless communication basically to send information then out, control signals for a cursor. And this is how it is actually looking like. They use an implantation robot that is actually kind of sewing these little electrodes into the brain. And there's also a patient, and there's, I think, a second patient study also going on, and there were some videos shown, not real data yet, but the patient apparently can very agile or very quickly and easily use a cursor on the screen to control, for example, playing chess very successfully. They have reports, I haven't seen it, but he reported that he was playing games like Civilization on this device. So there must be very fine control of the cursor here. You can see the cursor sometimes, this white round thing that is hopping around, and he can select things and move things on the board and so on. So that is a very good control as far as I can tell. Unfortunately, they haven't shown any data any real data yet. So you can also see that he doesn't have any kind of connector, so this is all wirelessly transferred. Okay, this leads us to like a small concept which we might also discuss in one of the many occasions where we have discussions, which is morphological freedom. So that is also very closely tied to virtual reality, which is the idea that it is a proposed civil right of a person to maintain and modify their own body. And there are people that are actually making use of that to do something that is called body hacking. So that is the new trend. So if you have kids, be careful that they don't start implanting stuff on their own and cutting themselves. And I'm just joking. Normally, this is done by adults that are implanting certain items into their body, or like particular surgeons that are doing that for them. You can see, for example, someone who implanted a magnet into their fingertip and now has this kind of magnetic, not really a superpower, but I mean, they can basically touch and feel actually metallic objects, because that will have some kind of will move, so the magnet in the fingertip will move, and that will cause a sensation, and then they can basically tell if there's something metallic around. And there are other people. This guy is colorblind, an artist who implanted something into himself to basically give himself the impression of color in a certain form. There's this thing that is called the North Ship. It's basically always telling where the, so it's like a compass, and it's implanted into the chest, and then it's also vibrating, so that you have implicitly a feeling of where the North Pole is. For what it is used, or what it is useful for, that's arguable. But as I told you in the beginning with the things that can be integrated into your body scheme, that all works. So if you use it regularly, then it will be integrated into your body scheme. And there's another artist, it's Stellark. He has done many, sometimes controversial stuff. Here he tried out a third arm and how that integrates into his body scheme, or he implanted like this little ear, so that's like some kind of, I think it's a plastic ear under his skin with a microphone actually. So he's doing all kinds of weird body hacking stuff. And with that, so that is the beginning of this physical body hacking. But in virtual reality, of course, you are completely limitless what you can do. So we come to the virtual bodies, and particularly to what is called an avatar. So I will come back to the theme from the beginning of the talk. So the movie Avatar, the title Avatar is actually from Sanskrit, and it means, or it is a concept in Hinduism that means the descent into the physical reality. So a representation of a god on earth, basically. And very prominent in this regard is the, so I don't know if you have people here that are more knowledgeable about the Hindu religion, but here we have Vishnu, for example. That is one deity that has many representations, so that is one of them. And I found that very funny that this guy here, so Vishnu, in this reincarnation has a bow and is kind of blue. And now compare that to the guy from Avatar. So I wonder where the inspiration came from. There's also, if you look at these Hinduistic avatars that are representations of the god on earth, as I said, there is not only one, there's many, multiple ones that look completely different genders, even some chimera between different animals. That is very old religious texts where this is mentioned, and now look at what people are doing nowadays in modern computer games. So these are the 10 avatars of a League of Legends player. So we are trying to start to do the same thing. We are creating multiple avatars of ourselves, representations that can look quite different from ourselves, that are doing stuff for us in virtual reality, and we are also integrating them into our own representations. Yeah, transferring the sense of self, that is something that can very easily happen in virtual reality, also in simple computer games. So as soon as you have something that is controllable by yourself, where you have feedback, so you need feedback, you need control, agency, and then very quickly you are not saying there is this pedal, but you're saying this is me, I'm this pedal, in this two-dimensional representation, I'm this pedal that I'm controlling, but you're not thinking anymore of this as something external. And that has gone through time over developments, has gone further and further. So you had Pac-Man after a while, then Mario, for example. There you can already see that there you are controlling this little avatar that already has some human features. Then we had the advent of all these so-called shooter games where you had the perspective of that person. That was very new at that point in time, and now it's like super. I mean, it has been controversial because people are claiming that you are getting more violent when you are playing violent games in these situations, which has not been proven. But I'm just saying that this is something that developed over time, and nowadays you have like avatars that look superhuman or very, very similar to you. So close to humans that you are probably cannot even distinguish that. So here you have Keanu Reeves in Cyberpunk 2027. With virtual reality, you cannot only see those avatars on the screen as what has been done before, but you can actually embody them fully. So this is an older picture from the lab where we reconstructed some parts of the lab and controlled a body in here. And that is one of the studies that one of my students did a while ago about virtual reality and the so-called alignment error. So he wanted to know how much of the control problem that you have when you are controlling a robotic arm, how much that is attributable to how the robot arm is positioned relative to your own arm. So he has positioned a robotic arm like the one that Eric had, the tetraplegic, in a virtual environment and try to draw something, and he noticed that the more this position is diverting from your own position, the harder it gets for you to control it. And then we have something very recent that art and PhD students in our lab were looking at, which is called the phantom touch illusion. So the idea is there that people noticed, or Art and the team noticed, that if you are touching something in virtual reality, then you might get some kind of sensation of touching something in reality as well. So the experiment looks like this. So you have a virtual stick that you are touching. You are touching your hand with a virtual stick with the other hand in virtual reality, and as I said, people report some kind of sensation here. So this is not magic or anything like that. The thing is that your internal body representation is trying to make sense of that, so that there is something that is moving along with your real arm, and it would expect now, so we are a prediction machine, it expects that there is a touch, but the touch doesn't come, so you get some kind of weird feedback information of, or at least that's what we assume, that in the brain is created because the brain anticipates a touch. And this is just some data from that paper where basically most of the people were reporting some tingling. But if you want more information about that, Art is the right person to ask later on. But you can also use virtual reality as like social spaces. We will have talks about that as well. So this is one of the very early social spaces called Second Life. So the idea was you have a second life in virtual reality. You can create your avatar in whatever way you are. This is actually not so new. The hype was around 2006, 2008, something like that. So these avatars become more and more human-like, as you can see here, and you can socialize around there. You can build houses in virtual reality, and people were really, I mean, there was like people who got really rich by renting out or property in virtual reality, not real land, but virtual land. And people are paying lots of money also for virtual items nowadays, right? But in Second Life, you would even marry. So there were people who married in Second Life and not in real life sometimes. And sometimes they did also marry in real life. So that was an article from The Guardian also in 2008, though there was this super hype. Unfortunately, this environment is not so active anymore as far as I know. But maybe we see something similar with the metaverse of Meta again soon. And we are almost reaching the end of the talk and can talk about the more speculative things or the things that are more fundamental. For example, what is actually real? Last year we had a speaker here, but he was not actually physically here, but he gave a talk from Australia, David Chalmers, and he was presenting his book, and this is about reality and virtual reality and how we can, or if we can distinguish it. I have this little clip here from the movie The Matrix, right? One of those iconic movies from 1999. Oh, actually, we don't have sound, or is it just to play?
What is real?
Ah.
How do you define real? If you're talking about what you can feel, what you can smell, what you can taste and see, then real is simply electrical signals interpreted by your brain.
So that was basically Morpheus, one of the characters explaining Neo, the other character over there, that actually what we are touching here and what we are seeing could as well be some kind of simulation. And the better our virtual reality technology becomes, the more feasible this idea becomes for many people, which has led to the simulation argument that was talked about by all these tech giants, like Elon Musk was talking about that, Nick Bostrom, many people were talking about that, and also David Chalmers. And the idea is basically, what if our brain is like in the movie The Matrix, in some kind of vat, and all the impulses are coming, the electrical impulses are simulated from a simulated environment, and we are just receiving them as an illusion, kind of. But the good thing is, so there's this book called Reality Plus from him that is a very good read actually about that. He talks about all the possibilities, but the key thing that he was talking about is that even if that's true, it's not too bad, because reality or an experience in virtual reality is as valuable as a real experience. That is at least the conclusion that he came to. And with that, I want to conclude today's talk. So we've seen that what we think is our body is actually a creation of our brain. And these brain representations can in many different ways be manipulated by physical manipulation or by very smart experimental setups. And virtual reality will very likely blend these boundaries more and more over time, especially if you are considering augmented reality as well. And one tip for you, watch more science fiction. There's good stuff out there. Just don't watch the wrong stuff. Thank you.